Hi guys, good to see you. Today I'm going to introduce one of the proofs of the Pythagorean Theorem. But what is the Pythagorean Theorem? For a right triangle, let A, B, and C be the length of base, height, and hypotenuse respectively. Under this condition, we have the equation A squared plus B squared equals C squared. This is a statement of the Pythagorean Theorem. It is really true for right triangles of any size or shape. How can we prove this theorem? This time, there are two important points in proving this theorem. Number one, make a square by arranging 4 copies of this triangle. Number two, calculate the area of the square in 2 different ways. This time, let's focus on this arrangement. We can see the square as a combination of 4 right triangles and a small pink square in the middle. We can also consider this square as one thing, shown in blue. Let's find the area of each of these two. The area of this triangle is 1/2 AB. The length of one side of this pink square is A minus B, so its area is the square of A minus B. On the other hand, the side length of this large blue square is C, so its area is C squared. Now let's actually calculate the left-hand side of this equation. 4 times 1/2 AB equals 2AB. The square of A minus B in parentheses is A squared minus 2AB plus B squared. 2AB and negative 2AB cancel each other out. This brought us to the conclusion A squared plus B squared equals C squared. One might say that, didn't we just prove the case where A is greater than B? So let's consider the arrangement of 4 isosceles right triangles with A equals B. In this case, there is no small pink square in the middle. We can also consider this square as one thing, shown in blue. Let's find the area of each of these two. The area of this right triangle is 1/2 A squared. So the total area of these 4 is 4 times 1/2 A squared, which is equal to 2A squared. The length of one side of this large blue square is C, so its area is C squared. Then we get the equation 2A squared equals C squared. Since 2A squared equals A squared plus B squared, this is equivalent to our final conclusion A squared plus B squared equals C squared. This time, let's focus on this arrangement. We can see the square as a combination of 4 right triangles and 1 small blue square in the middle. We can also consider this square as one thing shown in pink. Let's find the area of each of these two. The length of one side of this large pink square is A plus B, so its area is the square of A plus B. On the other hand, the area of this right triangle is 1/2 AB. The length of one side of this small blue square is C, so its area is C squared. So the total area of these 4 triangles and the blue square in the middle is 4 times 1/2 AB plus C squared. Now let's actually calculate both sides of this equation. The right-hand side equals A squared plus 2AB plus B squared. The left-hand side equals 2AB plus C squared. We can remove 2AB from both sides. Then we get the conclusion. A squared plus B squared equals C squared. Let's think about an application of the Pythagorean Theorem. I'd like to introduce an important formula for trigonometric functions, that is, cosine squared of theta plus sine squared of theta equals 1. First, let's review the definition of cosine and sine. In a right-angled triangle, suppose that the length of the base, height, and hypotenuse are A, B, and C respectively. And the angle between the hypotenuse and the base is theta. Under these conditions, cosine theta is defined as A over C, and the sine theta as B over C. So now let's just calculate cosine squared theta plus sine squared theta. This is equal to A squared over C squared plus B squared over C squared, which equals A squared plus B squared over C squared. According to the Pythagorean theorem, A squared plus B squared equals C squared. Then this is equal to C squared over C squared, which is equal to 1. I'd like to introduce another application of the Pythagorean theorem. It is the formula for the distance between 2 points on the coordinate plane. Let the coordinates of point P sub 1 on the xy plane be x sub 1, y sub 1 in parentheses, and the coordinates of point P sub 2 be x sub 2, y sub 2 in parentheses. And the D represents the distance between these 2 points. Now we can see a right triangle here. We can also see that the length of the base, height, and hypotenuse are the absolute value of x sub 1 minus x sub 2, the absolute value of y sub 1 minus y sub 2, and D respectively. According to the Pythagorean theorem, D squared is the sum of these 2 squares, so we get the formula D equals the square root of x sub 1 minus x sub 2 in parentheses squared, plus y sub 1 minus y sub 2 in parentheses squared. Thank you so much for watching this video until the end. I really hope this video will help you deepen your understanding of the Pythagorean theorem and its proof. I look forward to having fun learning math with you in the next video. Have a great day.